On behalf of our entire team, I welcome you all to the first session of Code Crunchers, a forum where coding becomes a passion. First of all, I'll just give you a brief introduction. My name is Muhammad Faik Ahmed. I've just cleared my ICSC board examinations with 95.2%, and I'll be your instructor throughout these sessions. Now, let's continue. Before we begin the topic, I'll first like to ask you, is any of you familiar with Java or any other computer coding language? That's great. We have a candidate who is familiar with one of the computer languages. Okay, now I would like to ask you, while registering for these code cruncher sessions, did you had any such query or doubt that why and what is the need to learn Java or any other coding language? I'll be clearing that misconception and doubt for you. See, the first benefit of learning Java or any other coding language is that it helps you to improve your creative thinking and logics. Because 70 to 75% of a program is already cracked once you understand the logic of that program. The rest 20 to 25% of the program is just applying your logic in the code. So it will boost your logic. It will boost your creative thinking. The second thing, because Java, it is a beginner-friendly language, and it is an object-oriented programming language, OOP. We'll be coming to it later in our session. And so if you learn Java, you'll be able to easily grasp and understand the other object-oriented programming languages such as Python, because all of these work on the same framework. And hence, it will be easy for you to grasp and understand other OOPs. And the final thing is academic benefit. Most of you or many of you would be going to give your ICSE or any other board examinations. And if I tell you about ICSE, about 90 to 95% of the computer paper is all about Java programming. And hence, it will benefit you academically, it will benefit your creative thinking, it will benefit your logics, it will help you to easily grasp other languages. Okay, so now I'll be starting the screen sharing and we'll be starting with the topic. Okay, so introduction to Java. Java is a high-level language and it is an object-oriented programming language. High-level languages are those languages which are user-friendly and beginner-friendly. It is also an object-oriented language, that is, the programs of Java are divided into small functions and objects. It was developed by James Gosling at Sun Microsystems in 1995, which is now known as Oracle Corporation. One of the major benefits of Java is that it allows you to write once and run anywhere. That is, it does not require any specific platform to run its programs. You can just write its code on any one of the devices or program, and you can run it on any browser, any platform. Now, the basic features of Java. Java is a simple language. I told you that it is a high-level language, user-friendly. It is object-oriented language. It works on the creation of classes and objects. It is also a platform-independent language. The thing I told you, it works on the principle of write once, run anywhere, Quora. It is a secure language. It allows you to troubleshoot easily. And why it is a secure language? Because it works on the concept of data hiding. Data hiding is one of the basic concepts of all of the object-oriented programming languages. It is a robust and portable language. It is easy to read, easy to use, beginner-friendly. Now I would request you to keep your pens and papers handy and write these features of Java in a concise manner. Then we'll go to the next topics. Now let's continue. Now the thing about high-level language, I already told you that high-level languages are programming languages closer to human languages, means it will be easy to understand for beginners, and they abstract away hardware details. Abstraction is a basic function that works on the concept of data hiding I told you earlier. It means that your data means the code of the program. It hides away the means a complicated part of the program and only reveals the means things needed by the user. So high level languages are Java, Python, C++. All of these are high level languages. Now the basic functions based on high level languages. It has a human readable syntax. It has no manual memory management, means it stores memory when objects are created. It has built-in libraries. I'll tell you about libraries. Now, why learn Java? Okay. Java is used for creation of Android apps, desktop apps, websites, and games. Means it's still used. There are one or two more languages which are there for this, but Java is still used for creation of Android apps, desktop apps, websites, and games. It is easy to learn for beginners, I already told you. And it teaches core programming concepts because it is an object-oriented programming language. It teaches the core programming concepts of means every OOP, because OOP stands for object-oriented programming. No need for learning Java. This is also the same thing because it helps you understand object-oriented programming. It helps you to build real-world applications because I told you that Android and most of the desktop apps are coded using Java. And the thing is, now the academic things that it is part of our school curriculums, and it provides for a good competitive programming, and it will help you in future interviews and all. Execution model we'll do afterwards. Programming structures we'll do tomorrow. Now we'll come to OOP. Object-oriented programming is based on objects. Objects are entities with data and behavior, means you can store data in objects. Now there are 4 pillars of OOP which we'll be delving into great detail. The first one is encapsulation. Encapsulation is, you can write this definition. Encapsulation is wrapping up of data and functions into a single unit called class. That is, if you have created a program, it has to be bundled up. It has to means include all of the methods of the program in one single file, in one single unit, which is known as a class. So encapsulation is wrapping up of data and functions into a single unit called class. It also works on the concept of data hiding. That is, for example, if you have created a program and I, as a user, am trying to use and run that program, I won't be shown its inner details because all of the inner details are encapsulated into a single unit called class. I'll be only seeing the outputs. I won't be seeing any inner detail. So that's the thing. It works on the concept of data hiding, and it can be defined as wrapping up of data and functions into a single unit called class. Classes and objects are the next topic. We'll be covering them also. I request you to continue writing it up in your note registers or diaries. Hope everything is clear up to now. If you have any query up to now, kindly inform me in the chat box. Okay. So it's all clear up to now. So we did the encapsulation. I hope you understood it. Now about abstraction. Abstraction is a very similar concept to encapsulation. Encapsulation works on the principle of data hiding, and abstraction also works on the same principle. The only thin line of difference that we can call a hairline of difference is that abstraction also reveals the data. It only hides the complexity of the program, and the necessary data is revealed in abstraction. Okay. So abstraction only hides the complexity of the program. That is, it also works on the concept of data hiding, but it only hides the complexity of the program. It reveals the essential data to the user. Whereas encapsulation works on total data hiding and only reveals the output to the user. On the other hand, abstraction only hides the complexity of the program and reveals the necessary functions. This is These are the among the pillars of object-oriented programming on which Java works. Now, inheritance. Inheritance is reusing code from parent classes. Means, for example, I created a program and I want to use the data of that program into another similar program. Then I can inherit the data of that program into the other program. Means it is a function of Java that its data can be reused. It is reusability feature of Java. So data from one class can be inherited into the other. This thing is known as inheritance. Now the fourth point is polymorphism. Polymorphism, many forms of one interface. Polymorphism means like an about intermediate concept. For example, there's a thing known as constructors and functions of Java. That means we can we can reuse different constructors and functions again and again in a program. Means the interface would be only one, but it will have many forms in the program, because Java, it divides the whole program into different functions, into different objects. So we can, for example, we can use only one function throughout the program for different uses. That thing is polymorphism. Functions, it is a advanced topic. We won't be doing functions here in these sessions, but just for your knowledge, polymorphism, because it is a basic pillar of Java, that's why I explained it to you. It just means that many forms can be used of a single function, of a single object. So just summing it up once. So 4 pillars of OOP, basic functions of Java. Encapsulation, the definition is already given. I have written it. Abstraction, revealing only the essential details, hiding the program complexity. Inheritance, reusing the data of one program in the other. And then polymorphism, many forms of one interface, that is, what I told you, functions or objects of Java, which can be reused for different purposes. I hope you have noted up to there. Okay, I'll just go through abstraction once again because a candidate has requested it. Abstraction is just like encapsulation. Encapsulation was wrapping up of data and functions into single unit called class. Encapsulation worked on the concept of data hiding. It hid the entire data from the user. Whereas abstraction only hides the complexity of the program. It just hides the complexity of the program and reveals the essential details to the user. Encapsulation did not reveal any detail to the user, whereas abstraction reveals essential details to the user. That's the difference. Okay, hope all is understood up to here. If you have any query up to these pillars of object-oriented programming, kindly inform me. Otherwise, we'll continue. Okay, so you don't have any query. Okay. So before we begin with the next topic, classes and objects, it is already time for the first break. The break will be of 5 minutes, and you are requested to join the session again by 11:05. I'll be sharing a new link for the session. You are requested to go through your notes in this break to rehydrate and just go through the notes once again, to ask anything from here if you have missed anything in the next part of the session, which starts from 11:05 and will end at 11:45. Okay, I'll again go through encapsulation after the break. You all are requested to join at 11:05. Now I'll be ending the meeting. I'll send you a new link, which you'll be joining at 11:05 maximum. Okay. And first we'll then go to encapsulation, and then we'll start with class and objects in Java. You all are requested to go through your notes in the break. Okay. I'm ending the class now. Okay, welcome back. I hope you all are refreshed and you went through your notes. Okay, so first, encapsulation. Yes, encapsulation works on the feature of data hiding in Java. It hides the complexity as well as all of the things of a program. It encapsulates it into a single unit known as class. Now, before I'm going to share my screen. Is there anyone who would like to just brief all of the topics taught till now? I'll unmute that person. The candidate may raise their hand. That's great. One candidate has raised his hand. Okay. I request him to unmute himself. Okay, so brief about all of the topics taught till now. Are you speaking? Yes, start.
Yes. Am I audible? So we went through 4 topics: encapsulation, abstraction, inheritance, and polymorphism. According to what I understood by now, so encapsulation is basically wrapping up of data and functions into a single unit called class. And abstraction is re- uh, revealing only essential details, hiding the program complexity. Inheritance is reusing code from parent class and reusing the data of one program in the other.
Okay, that's great. You understood it very well. Now, I hope all of the other candidates also would have understood all of the topics. Now, I'm going to reshare my screen and we'll do objects and classes. If at any point during the class I'm inaudible to you, you may inform it to me in the chat box. Okay. Now I'm sharing the screen. Okay, is the screen visible? Is the screen visible to you all? Great. Now class and objects. In encapsulation, I used a term class. When explaining encapsulation, I told you that it is the wrapping up of functions and objects into a single unit called class. Now, what is class? Class is a blueprint to create different objects. It is the encapsulated form of of the whole program. If you want to see the code of the program, you will be able to view it in the class. Class is just like a blueprint which you use to create different objects. And objects are the instances of the class. For example, if I tell you red color, so red is an object of the class color. Means class is color. It is the blueprint, the instance of which is red, which is a particular color. So class contains all of the objects which are created in a program. A class contains all of the objects which are created in a program, and those objects are the instances of that class. For example, if we talk about colors, then color is a class which encapsulates all of the individual colors. For example, red is a particular object of that class. If we talk about flowers, then flowers is a particular class, and rose, lily, tulip, all of these are particular objects or instances of that class. Because Java is an object-oriented programming, it works on the creation of objects throughout the class. So while creating a program, you will be needed to create different objects or instances of the class. The whole program and the whole code, it is encapsulated in a single it is bundled in a single form known as class. It is the blueprint for the whole program, and objects are instances of that blueprint class. Now the syntax for it is the way in which you write the code. Syntax we'll do afterwards, because today I'll just explaining all theoretical part to you. And from tomorrow, we'll be doing the structure of the programs and how to create programs. We'll do day after tomorrow. So this thing that is written class, car, and brackets, it is known as the syntax. Syntax is the manner in which you write a particular snippet, particular part of a program. We'll be doing syntax and all of that maybe tomorrow. Now, the most important thing. First, I'll go through variables. Now, if in Java programs, we need to store data. For storing data, we use variables. Variables like in math, we use let x be the unknown quantity. So in a similar manner, variables we can say are containers which we name for storing data values. It allows the program to store and manipulate data. For example, if we want to store the number 5 in a program, we'll store it in a variable. For example, I use the variable a. I'll store it in the variable a, and then I can do the different functions over that variable. For example, if I want to increase the value of a, if I want to add the value of a to another value, all of these operations will be conducted on the variable, and the result will be visible to the value stored in the variable. So variables can be understood as containers which we name for storing data values. Because in Java programs, we would be required to store data values, and the values will be stored in variables. There's one important thing. Unlike Python, because in Python, you don't have to specify the type of data you are going to store in the variables. Whereas in Java, you have to always specify the type of data you will be storing in variables. For example, if it is a name, you have to first specify before writing the variable. For example, if I take the variable name as AB, so before storing the data into AB, I'll first specify that what type of data can be stored into AB. AB is the variable, the container which I've created to store a kind of data. So before storing the data in AB, that is the variable, I have to specify what type of data can AB store. If it is a name, I'll have to specify it. If it is a number, I'll have to specify it. Clear? Now I'll come to data types. Data types is the thing I was telling you about, which we use to specify the type of data to be stored in the variables. Data types, I repeat, are used to specify the type of data to be stored in the variables. I hope you are following with me and writing it. So data types reveal to the computer compiler that what is the type of data you are going to input into the variable. So there are two main types of data types in Java. One is primitive data type, to which we'll be going to lengths and breadths in our sessions. And the other is non-primitive data type. We'll not be doing non-primitive data types in these sessions, because in these sessions, we'll be focusing on integer-based programming. Okay, just one moment. A candidate wants a re-explanation of variables. Variables are like containers which are used to store data values. And for example, the variables like you use in math, you use them to store data values, and before storing values into it, you have to specify the type of data, the type of value you are going to store into it. For example, if you want to store a name, you have to specify it first. If you are going to store a number, you have to specify it first. I hope it's clear now. The candidate who requested, kindly inform me if it is clear or not. I hope variable part is clear to all of you. Okay, great. Now I come back to data types. Okay, so Java has two types of data types. One is primitive data types and one are non-primitive data types. Primitive data types are those data types that are built in the Java, that come preloaded in Java. And non-primitive data types are those data types that are created by using the primitive data types. Okay, so These 8 are the main primitive data types of Java, and we'll be going to many of them throughout our sessions. You're requested to understand this table thoroughly, because variables and specifying the type of variables, the type of data to be stored in the variables is one of the basic things of a program. And if you understand it, it'll be very easy. So the first variable I am going to take for explanation is byte. We'll not be doing ranges because that's not needed just now. So, okay, so the first type, we can divide all of these into 4 main categories, or I can say three to 4 main categories. Yes, the first one are integer based variables. Wait, I'll write it down. The first 4: byte, short, int, and long, all are integer based variables. The second group can be classified as floating point variables, or you can say decimal storing variables, data types. The third group can be taken completely differently because it's for storing characters. You can store different characters like A, B, C, D, or you can store characters at 1, 2, 3, 4 also as a character, not as a number. And the last one is Boolean. In Boolean, it is used in conditional programming. We'll do conditional programming also in our sessions. In that, the program requires to give an output of true or false. In that, Boolean data types will be needed. Okay. And so the first type, integer variables, not integer data types. The first one is byte. Its size is 1 byte. It is the shortest data type, the smallest data type. It uses the least memory. 1 byte is equal to 8 bits. You may write it, 1 byte is equal to 8 bits. 1 byte is equal to 8 bits. The default value means, if, for example, if you store a variable byte A and you do not assign a value to it, then the Java compiler would give it a default value of 0. Range we are not doing. Second thing, short. Short is used to store numbers, and it occupies memory somewhat more than byte. It occupies 2 bytes of memory, that is 16 bits, because 1 byte was 8 bits, so 2 bytes is 16 bits. Its default value is also 0. Now, integer. It is one of the most used data type for beginners in Java, int. It has a storage capacity of 4 bytes. 4 bytes, that is 4 into 8, 32 bits of storage. Okay. 1 byte is equal to 8 bits. Therefore, 4 bytes will be equal to 32 bits of storage. Its default value is also 0. Now, long. It is used to store large numbers. For example, if I want to store 11-digit number, if there's a variable A and I want to store a 11-digit number in it, for example, the ISBN number of books. You must have seen books. At the back cover, there's a number written, ISBN number with a barcode. If I want to store that number in a program, then I would be using long data type. To store large numbers, it has 8 bytes of storage, which means 64 bits of storage. It occupies the largest amount of storage among the integer data types. Its default value is also 0, L for long. Very large values it stores. I'll just summarize it once. Integer data types. The first one being byte. It is used for storing small values, very small values. We'll not be using byte and short as frequently as we'll be using int, because int is the most used. So byte stores just 1 byte of storage. 1 byte of storage is equal to 8 bits of storage. Okay, so it stores just 8 bits of storage. You're requested to note that 1 byte is equal to 8 bits. Okay, so byte is the smallest data type for storing small values, and its default value is 0. Then comes short. It stores 2 bytes of storage. 2 bytes is 16 bits. Its default value is also 0. Now, int. For example, if I want to store a value in a number like 568. So I'll specify INTA. First, I'll tell to the program that the value I'm going to store in A is a number, because integer variables, byte, short, int, long, all of these store numbers only. You may write it as an asterisk, that integer variables store numbers which are whole numbers without decimal. Integer data types, okay? Byte, short, int, long, all of these store whole numbers, and the most frequently used one will be int for these sessions. And then comes long. Long is for very large values. It stores 64 bits of storage, or I can say 8 bytes of storage. Its default value is also 0L. Hope integer data types are clear to you all. Kindly inform me in the chat box, and if you have any doubt, then kindly inform me in the chat box or raise your hand. Okay, they are clear. That's great. Now I come to floating point data types. Floating point data types are for storing fractional values, decimal numbers. For example, if I want to store 1.532 in Java, okay. A good question. What is the meaning of default value? I told you in the beginning, when I was informing of primitive data types, that, for example, if I used a variable in Java, and while declaring it, variable declaration will come to later, probably tomorrow, but just for an overview, while declaring a variable, for example, while writing the variable for the first time in the Java code, if, for example, if I write that it is INTA, this will inform the compiler that A is a variable in which a number will be stored. But I have not assigned any value to A. So Java compiler will give it a default value, will give it a value by default, and that value will be 0. For example, if I do not, summarizing it, if I do not give a value to a variable while declaring as in writing it for the first time in the Java compiler with its data type is the type of data to be stored into it. When I'm writing a variable for the first time, if in a Java program, and I do not assign a value to it, then the Java compiler will give it a default value, will give it a value by itself, and that value will be 0 because it is INT. Okay, hope it's clear now. Okay, now I'm coming to floating point data types. Okay, floating point data types. These data types are used to store decimal numbers, fractional numbers. The first group of data types which I explained to you, which were integer data types, those were for storing whole numbers only. That is, numbers without decimals, without points, without fractions. But these floating point data types, they are for storing numbers with decimals. For example, if I want to store 1.532, then I'll be using float or double. These are the two data types. Float has a storage capacity just like INT. Its storage capacity is of 4 bytes, that is 32 bits of storage, and its default value is 0.0f because these are decimal numbers, so the default value is also 0.0. And then double has a storage capacity just like long. For example, if I want to store a big decimal number like 1.32856732, then I'll be using double. It is a storage capacity of 8 bytes, that is 64 bits, and its default data type is also 0.0D. It's not written D here, just wait. D for double to understand it. Okay, for example, if I want to store a value, I'll first go for int. If I want to store 4 in this A, the variable I took int A, so I'll write int A is equal to 4. And then I'll apply a semicolon. Semicolon is just like a full stop in Java. If you do not apply a semicolon, your program would not be compiled. It will not run. So just after every sentence in English, we put a full stop. In Java, we put a semicolon. This thing will come to it tomorrow. I was just giving you an overview. And if I want to store a number with decimals, for example, I'll take double 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 D is equal to 1.5384, any number I can take. So if I wanted to store a decimal number, I would store it in double or float. And if I want to store a whole number, I will store it in any of the integer data types, and I would recommend you to use int. And for floating point data types, I would recommend you to use double, because it means the one which can store higher ranges of values. And for example, if we want to multiply two values of decimal, then obviously we're going to get a higher value in points, so double would be a better choice. Now, if I want to store characters, for example, if I want to store A, B, C, D, or if I want to store even numbers as a character, for example, if I want to store 1 as a character, not as a number, then I would be using char data type. It also has a storage of 2 bytes, that is 16 bits, and its default value is given /u000. Now the default value, it's not that needed in char, because obviously you will assign values to it if you're using char data type. Char is for storing characters. I'll just give you a little bit of syntax of char also, as I've given for the previous two data types. For example, if I want to store A as a character, then I'll name any variable. For example, the name of the variable I'll take char n is equal to, and all characters are stored in single quotation marks. So now if anywhere in the program I use the variable n, then only the value of A will be revealed into it. Okay, means n is storing the value, the character A. If I want to use A, I'll be calling n. It's just like mathematics. We are using a variable. It's just like algebra. We're using a variable, and in that variable, we are assigning values to it, be it numbers, be it decimal numbers, be it characters, and then Boolean will do as it comes to our in our programs. Okay, because it is for conditional programs, and conditional programs we'll be doing maybe in the second or third week. But for now, integer data types, floating point data types, and character data types, you must understand them thoroughly. Integer data types are for storing whole numbers. Floating point data types are for storing decimal numbers or fractional numbers, and character data types are for storing any number, any alphabet as a single character in Java. Hope that's clear. Kindly inform me in the chat if you have any doubt or if it is clear. One quick review of floating data type. Okay, so floating point data type are used for storing decimal numbers and fractional numbers. There are two types, float and double. Float is for storing smaller values. It has a data capacity of 4 bytes, that is 32 bits of storage it utilizes. Its default value is 0.0f. It is used to store fractional or decimal value numbers, but I would recommend you to use double. Double data type is also used for storing the same thing, that is fractional numbers, decimal numbers, but it has a memory capacity far greater than float. It has the memory capacity of 8 bytes, that is 64 bits, and its default value is 0.0d. And if just for an overview, you can see that where float stores up to approximately 7 decimal digits, and double stores up to 15 decimal digits. So if you want to do multiplication or division of decimals, the best option would be double, and I would recommend you to use double only, the double data type. Okay, and character is for storing characters. There's a thing known as Unicode and ASCII values. These are assigned to all of the characters. When we'll be storing characters in Java, you will be informed all about that. Okay, but for now, you have to keep in mind all of these things. Okay, the integer variables, the 4 types of it, their size and their default value. It is the most importantly needed thing. floating point data types, it's two types: float, double, their size and default value. Then character, its size and default value. Boolean, its size is the smallest 1 bit of storage it just stores, and default value is always false. Its range is true and false because it returns a value of true or false only. It is used in conditional programs. Hope up to now it's clear. Kindly inform me in the chat. Okay. A candidate requested a re-explanation of int and double. See, data types in Java are of two types: primitive data types and non-primitive data types. Primitive data types include these 8 data types which are in front of your screen. These can be further divided into 4 types. The first 4 integer data types, the next 2 floating point data types, the next one character, and the next is Boolean for conditional programming. For example, Boolean is used, for example, if you want to check whether a number is equal to this number or not, or whether number is even or not, for these things. If you want a condition to means run in the program. Okay, so int and double. Int is used to store whole number data values. For example, if I use a variable a in the program, then I'll have to specify what type of value can a store in it. Can a store a name? Can a store a number? Can a store a whole number? Or can a store a decimal number? So in this case, I want a to store a whole number. So I'll write int a. Int specifies to the Java compiler, to the Java machine, that the values being stored in a should be a whole number. It has its storage capacity of 4 bytes, that is 32 bits, and its default value is 0. Similarly, if I want to store a decimal number in a variable b, then I have to specify what type of value would be means taken into b. So I'll write double b, and then I'll store the value 1.538 to whatever the decimal value I want to store. Double, its storage capacity is 8 bytes, that is 64 bits. Hope you all have understood up to here. Kindly inform me in the chat box. Okay, that's great. The candidate understood. Now we'll keep it up to here today. Tomorrow, I'll be informing you about the rules which are required for naming variables, because any type of data cannot be used as a variable. I can use A, B, C, D. I can use a combination of the characters, but not all characters can be used as variables. So we'll be understanding the rules which are required for naming variables. And also we'll be doing something known as Java packages, because Java packages will come to it in the last week of or the second last week. So we'll be doing it tomorrow. We'll keep it up to here. And just one more thing I'll tell you today, that is Java is a case sensitive language. In Java, if I take 2 variables, one I take small a and one I take capital A, both of these will have different meanings to the Java compiler. It is a case sensitive language, so it takes a difference between uppercase and lowercase letters. It do not take them as the same. So we'll keep it up to here today. Tomorrow we'll continue. I'll first re-explain about case sensitivity of Java. Then I'll go to data types, then the rules for naming variables and the type of packages. And then we'll come to the structure of programs so that you are able to construct your programs by yourself. Hope you understood up to here. If you have any query, you can ask. Okay. So hope no one has a query. We'll continue tomorrow. Till then, hope you enjoyed the session.